Today we are going to go over the different types of non-Mendelian inheritance patterns that we talked about in class. So if you remember back to Mendel, you know that he looked at just the simple dominant and recessive traits, and everything was very simple and easy. But then we moved into talking about things like polygenic traits, incomplete dominance, sex-linked traits, multiple alleles, and something called codominance. So just to refresh our brains quickly here, polygenic traits are controlled by 3 or more genes. Incomplete dominance is when the phenotype of the heterozygous individual is intermediate to the homozygous individual. Sex-linked traits are controlled by alleles found on the X or Y chromosome. Multiple alleles are traits that are controlled by more than 2 alleles. And then codominance is when the phenotype of the heterozygous individual shows the phenotype of both alleles. So when it comes to this list of non-Mendelian inheritance patterns, the two that people often get mixed up are incomplete dominance and codominance. So incomplete dominance is when the heterozygous individual, so like big R, little r, this individual would have the blended phenotype. So if big R is red and little r is white, an individual that's big R, little r would then be pink. And for codominance, if the individual is BW, then they would show the phenotype or the color that both of these alleles code for. So this would give us like a black and white speckled chicken. So let's do an incomplete dominance practice question together. So in snapdragons, color is controlled by incomplete dominance. Big R is the red allele and little r is the white allele. If a red flower is crossed with a pink flower, what is the chance that the offspring will be pink? So we are doing a cross here between a red and a pink flower, which means we're crossing a homozygous dominant flower with a heterozygous flower. So how do I figure this out? Well, we need to set up our dear friend, the Punnett square. So make sure you are putting the alleles for the parents on the outside, and then you fill in the possible genotypes of the offspring in the middle. And then you just go back to your question. What is the chance that the offspring will be pink? Well, pink flowers are heterozygous, and I see 2 of them right there. So 2 out of 4 are heterozygous. They'll be pink, and so my answer is 50%. All right, now for a codominance question. In chickens, color is controlled by codominance. The big B allele is black and the W allele is white. What is the chance that a heterozygous chicken and a white chicken will have speckled offspring? Okay, so again, we're setting up our Punnett square between a heterozygous chicken, which would be BW, and a white chicken is going to be WW. I fill in my Punnett square like that. And back to my question here, what's the chance that my chicken will be speckled for the offspring? So which ones are BW? It looks like there's 2 out of 4. So again, my answer is 50%. All right, another popular non-Mendelian inheritance pattern that we looked at was actually the blood type. So remember there's 4 different types of blood, and they're controlled by 3 different alleles. So the alleles were the big I, big A, big I, big B, and that little I allele. And these alleles give somebody either type O, type A, type B, or type AB blood. And so if we were looking at a question like this one, so it says a woman who is heterozygous for type A blood and a man who is type O blood plan to have a child. What is the chance the child will be type O blood? Well, we just need to figure out the genotypes of the parents. So the woman is heterozygous for type A, which means she has to have 2 different alleles, big I, big A, little I. And then the man is type O, so he has to have both of the recessive alleles, so little I, little I. And then just like we always do, we stick those alleles on the outside of our Punnett square, we fill it in, and we can see now that 2 out of 4 of these possible offspring will be type O blood, which means our answer again is 50%. So in conclusion, we just need to remember that not all traits are as simple as what Mendel observed in his pea plants. There's many different types of inheritance that affect our traits.